here we are again, and we're going to delve into topic 7.5 and 7.6. 7.5 is indoor air pollution, hence the picture here, and topic 7.6 are things that we can do to reduce air pollutants. All right, the reading to accompany this is pages 613 through 621. If you can find a nice hammock and a good outdoor location, good weather, I recommend going outside and reading if you can. Otherwise, pick your favorite spot inside your house or school or wherever, but do one way or another also do the reading to accompany this. All right, so we're going to start with a nice little factoid for you. And that factoid is that there are an approximately 3.5 million people per year globally who die uh, due to conditions created through indoor air pollution. 77% of those are in the developing world, and we'll talk about why there's more in the developing world than other places here in just a second. Now, in the developing world, because they often don't have electricity, right, and electric stoves or nicely ventilated natural gas ovens and so on, they cook over open fires in the indoors, and the particulates uh, and other types of pollutants emitted, including things even sometimes like carbon monoxide, uh, create exposure to dangerous levels. And one of the things we want to know about indoor air pollution, right, is that pollutants build up because there's a less atmospheric mixing inside a house versus outside. Pollutants build up inside our homes. We tend to spend more and more times in our home versus outside, uh, and so indoor air pollution is one of the number one causes of air pollution related illness and death. All right, but again, in that developing world, a big problem is the indoor cooking. All right. Um, So we're gonna look at some of the common indoor air pollutants, and one of the things you guys need to be able to do is identify some of these. Obviously, you're not going to need to give me or repeat an exhaustive list on a test or anything like that. You do need to be able to identify some, or at least if you're given some examples of pollutants, identify whether those would be examples of common indoor air pollutants or outdoor air pollutants, depending on the circumstance. And some, of course, are both. All right. Um, so volatile organic compounds, which we've already talked about earlier, as we talked about general air pollutants. Volatile organic compounds. Basically, we are referring to uh, uh, cleaners and solvents when we're talking about these things inside. So anything that volatilizes or comes into a gaseous state. So anything that tends to have a strong aroma, right? We often refer to those things as volatile organic. So most of your cleaning solvents, right, are VOCs. Lots of your glues and adhesives have VOCs. Paints of various types, carpet even, right? A lot of the compounds used in glues and paints and cleaning products have these volatile organic compounds. Some of them are quite benign and don't cause any trouble. Some are problematic. So VOCs are a common type of indoor air pollutant, right? Tobacco smoke. Obviously, if you don't live in a house of smokers, it's not as big of an issue, but it is one of the primary causes of illness related to indoor air pollution. Even if you were a non-smoker, that secondhand exposure can be problematic. Carbon monoxide, right? Again, if you have natural gas, typically natural gas heating, natural gas water heaters, etc. The combustion of natural gas in indoors, especially, uh, limits the amount of oxygen available for that combustion reaction to occur, which can result in increased amounts of carbon monoxide produced instead of carbon dioxide. And carbon monoxide, as we talked about previously, is a very, very dangerous gas. It gets up to certain concentrations. So your house ought to have a carbon monoxide detector in it if you have natural gas supplied to your home. I believe it's a code legally. You're supposed to have one. Okay. Asbestos in older homes, they phased asbestos out quite some time ago, but older homes do often still have it in the insulation or sometimes in like those spongy like popcorn ceilings. Right, those can get airborne and get lodged in your lungs, and it's linked to things like lung cancer. Particulates build up, particularly dust and mold. spores and stuff like that that can get in your lungs and cause breathing irritation. So those of you who suffer or deal with asthma, you may have noticed that in the winter months when your heater is running really frequently, that often kicks dust up in your house and causes irritation and increased issues with asthma. Nitrogen oxides can build up, and all kinds of things. All right. Also, uh, been phased out over time, but still a problem in older homes is lead that's in either in old pipes, but mostly when we talk about indoor air pollution, it comes from the old paint. And as people go around and maybe scrape old paint off old rooms or sand it down, that creates airborne lead dust that can get in. And lead is toxic. All right. So, indoor air pollutants, they are numerous. You want to be able to identify some of them, right? And probably be able to talk a little bit about what specific health concerns they might lead to. All right. So some important facts. As I mentioned earlier, air pollution indoors is often worse than outdoors. So common air pollutants are often 2 to 5 times higher inside your home than outside. The only time we might ask you to stay inside for better air quality is when there's particularly high levels of pollutants outside. So we're in those midst of those really heavy inversions, for example, that we get in the wintertime here in Walla Walla. Often outdoor air quality is worse than inside, then especially during wildfire season. Indoor air quality is generally much better when we have heavy wildfire smoke. But other times of the year, in general, outdoor air quality is much better than indoor air quality. Two, if you are in traffic and in your car, pollution level inside your car builds up to 18 times higher than the outside environment. All right. And people are spending increasing amounts of time indoors versus outside. Um, and presently in the US, people on average spend about 70% of their time inside buildings. So it's really important that we talk about potential air pollutants inside the house and how that might be impacting people's health. And there's actually even something called sick building syndrome, basically older buildings that don't have as many codes in terms of mixture of inside air and outside air with your heating and cooling systems. Perhaps there's lots of outdated and no longer used solvents or adhesives and paint and stuff like that. There's documented cases where buildings themselves, just by the nature of what they were built with, and how the airflow goes through them, cause much higher incidences of illness. And that's what we call sick building syndrome. All right. So we're going to talk about a special problem of radon gas. That was on that list just a little bit ago, but I wanted to put off talking about it. So radon is a naturally occurring air pollutant that we worry about indoors. So radon gas is produced through just the natural decay of trace amounts of uranium that are just in the ground around us, right? So radon is particularly problematic in basements, right? So we might have uranium present in just tiny little amounts out there in the soil. Okay, and as uranium decays, goes through its radioactive decay, one of the decay products is radon gas. And because it's a gas, it is able to kind of work its way through little micro cracks and fissures in our basement walls. It's also an especially dense gas, which means um, it is highly likely to get stuck uh, down in basements and low areas. So it's much denser than just the ambient air, for example. So there's a higher likelihood not only to be exposed to radon because you're beneath ground, but also for radon to slowly accumulate in low areas if there's not good mixing of air. All right. It's clear, colorless odor, so you wouldn't know it's there. And it can actually, because it's a gas, uh, we can breathe it in, and so it's a radioactive gas. And because we are breathing it in, we don't have that barrier of skin to sort of protect us. So it's much easier access to cells and things like that. Uh, so it tends to accumulate in our poorly ventilated low-lying indoor areas, right? It easily gets into your lungs because it's a gas, all right? And it can potentially cause things like lung cancer if exposure is prolonged over like long periods of time. Now, if you happen to have a basement bedroom, right, here in the Walla Walla Valley, and you're finding yourself being a little nervous about exposure to radon, good news is we don't live in a particularly high radon producing area, right? So here in Walla Walla, we're kind of in the medium range, right? Uh, but even in some of these higher range areas, it's highly unlikely that you're going to be exposed to enough radon, just in being in your basement bedroom, um, to enough that would really cause damage. Although though you can do various like take home radon detection kits and stuff like that, or you could take use like a Geiger counter and kind of get an idea of maybe how much ambient radon is there. Uh, and then you can do, there's some online calculators that help you kind of figure out like, oh, how many hours do you spend down there? What's the amount of ambient radon? How much radiation are you being exposed to? And does that put you anywhere near something that might raise red flags? Typically, even in the higher radon areas, the answer is going to be no there. So don't get too nervous about it, but it is something to be aware of and think about. All right, so we're going to move on to topic 7.6, which is reducing air pollutants. So first of all, let's differentiate between two terms, point source and non-point source. And this refers to both air pollution emissions and water pollution. In this context, obviously, we're going to talk about air pollution. But so controlling and mitigating air pollution is often difficult when we have what's called non-point source pollution, which basically means whatever is causing pollution comes from lots and lots of small emitters. Okay, so some examples there of point source pollution would be like coal-fired power plants and metal smelting. So basically where we can trace the emissions of certain pollutants back to a single spot. Much easier to deal with pollutants in that way because it basically just requires one, maybe one larger, but one single innovation or one single or a couple measures done at one location. Okay, if the pollutants are caused by thousands or millions of individual vehicles, we can't just go to one location and apply one innovation to clean up the air, right? It requires a much more robust process. So point source pollution, while highly concentrated single source, it's actually a little bit easier to mitigate because it'll come in from one spot. All right, so what can we do? Well, we can implement regulatory practices so we can basically tell certain factories or power plants that they're only allowed to produce X amount of pollution, right? And they need to go below that or suffer fines or even get closed down. Um, and there's some technological innovations we can apply to those areas, both point source and non-point source. And we'll talk a little bit about what each of those does here in just a second. All right. Um, we can implement conservation practices, which basically relies on the principle that if we use less, we will simply pollute less as a result. Okay. Or we can look at alternative fuels. So, for example, we have a coal-fired power plant. We can relatively easily transition that over to a natural gas fire plant. And just by virtue of switching fuel types, get rid of or reduce many of the pollutants we would associate with that. Okay, so there's lots of ways we can go about reducing air pollution. All right, so let's talk about the Clean Air Act first. So the Clean Air Act was implemented initially in 1970, but it's received updates in 1977 and 1990, and then probably some smaller cleaning up of the Clean Air Act amendments and the legal jargon and so on fairly frequently. All right, but basically what it did is that it established standards, air quality standards for six major air pollutants: carbon monoxide, nitrogen dioxide, sulfur dioxide, ozone, particulate matter, and lead. Plus, lead goes under those hazardous air pollutants, the HAPs we talked about before. All right. So there are very strict standards for those six major air pollutants, and whether it's a vehicle production company or an energy production, right? Everybody has to abide by the Clean Air Act in the United States or suffer fines. But it is worth pointing out that carbon dioxide, one of the major gases that we've talked about in this class, is not presently included as one of the air pollutants controlled under the Clean Air Act. All right. Now, Clean Air Act, it has been highly effective. So even though, right, we've seen an increase in gross domestic product, which is associated with the increased production of energy, more people driving, increased pollution, more cars on the road, etc. Despite all those increases, there's been an almost nearly 70% decrease in the emission and the presence of those gases in our atmosphere. So Clean Air Act has been highly effective. And in fact, if we go back to ice cores in Greenland, especially, uh, they can actually point to the layers in those older ice cores from 1970 onward. It can point to exactly when the Clean Air Act was implemented because uh, basically a lot of the pollutants, particularly, most importantly, particulates, disappear from the ice cores because we were highly effective at reducing their emissions. All right. So electrostatic precipitators are pretty cool. What they do is, if you take a look at a smokestack, for example, is they reduce particulate pollution specifically. Now, particulate pollution uh, can be attracted to these electrostatic precipitators through essentially electrostatic attraction. So if we take a look at the smokestacks in this factory, for example, with the electrostatic precipitators turned off, right, particulate pollution is an obvious problem. Remember, we can see particulates, but not gases. Okay. Now, simply turning on an electrostatic attraction causes those particulates, which are solids, to be attracted to an electrostatically charged rod, and they essentially fall out as dust, right? And so this factory is actually still in full operation, but notice the difference in the production of those gases before and after. Kinds of particulate pollution, turn electrostatic precipitators on, gone. All right. Now, another way, and this really helps with our sulfur oxides and nitrogen oxides, so our acid rain causing pollutants, is to install what are called scrubbers, right? And so basically what they do is they make use of treated water, often with certain additives to the water that they're not literally scrubbing the air like you might imagine, like a mechanical scrubber. What they're doing is chemically reducing things like sulfur oxides and nitrogen oxides in the exhaust gases so that they aren't able to escape into the atmosphere. So basically, every coal-fired power plant, every metal smelting uh, factory in the United States has these wet or dry scrubbers installed in their smokestacks. And essentially, what they do again is they reduce the sulfur oxides and often nitrogen oxides as well before they get out in the air and can, as a primary pollutant that leads to things like acid precipitation. Controlling things like volatile organics, uh, gas stations and so on have to utilize what's called a vapor recovery system. So when they refill gas tanks underground at gas stations, rather than letting those vapors just escape out into the atmosphere, they have to recover them in the same truck that brought the new gas in the first place. Um, and vehicles, being a non-point source pollution, all vehicles have to pass certain inspections for vehicle emissions. Um, and one of the ways that's done, aside from adjusting, air intake versus fuel intake, done on the combustion side in the engine, your computer really kind of regulates those things. They use what's called a catalytic converter on the exhaust side. So every car nowadays that burns gasoline, not electric cars, they don't need them, any sort of combustion vehicle has a catalytic converter installed on it. And basically, what that does, it works similar to a scrubber, in a smokestack, not an electrostatic precipitator, but like a scrubber would work to reduce like sulfur and nitrogen emissions. Catalytic converters do much the same thing. They have uh, chemicals present that catalyze certain reactions, help make sure combustion occurs more completely, right? So there's fewer particulates, there's fewer sulfur emissions, and so on. So catalytic converters help control carbon monoxide, nitrogen oxides, VOCs, etc., in our internal combustion engine emissions. All right. Now, I mentioned earlier that carbon dioxide is not controlled under the Clean Air Act, right? But the Clean Air Act has been highly effective at reducing all of the pollutants for which it was designed to address. So just imagine what we could do if we got carbon dioxide legislated into the Clean Air Act.